Okay, today we're looking at actually applying the logarithms and exponential equations and solving them as that we've been doing. So the first one we're coming back to are continuously compounded interest. Now we're going to see how long does it take. So we're solving for that t value. So we've got Michael has $5,000 in his checking account, invests $4,500 of that into an account that earns 3% interest compounded continuously. How long does it take for his investment to reach $6,000? And it tells us to use the formula A equals PE to the RT. First thing we need to do is plug our information into the equation. So we've got A equals PE to the RT. A is your final amount, so we're looking for an amount of 6,000, so that's going to be my A. P is what you put in. Now it gives me that he has $5,000 in his checking account, but he invests $4,500. He only puts in $4,500. He probably just leaves $500 in there just to be safe. So $4,500 is my P because that's the amount that's actually invested. 3% is my rate, but we need to make it a decimal, so 0.03 will be my R. And we want to know how long it takes, so T is what we're solving for. So when we plug it in, we're going to have 6,000 equals 4,500 E to the 0.03 T. Okay, so 6,000 equals 4,500 E to the 0.03 T. We're solving for T. So what we need to do is we need to get E by itself. So we need to get to where we have a base, the base alone, so that way we can take a natural log or a log of both sides. So step 2 is we're going to solve for exponent and its base. Okay, so we want to solve or simplify, isolate the exponent and its base. Probably better to say isolate the exponent and its base. Okay, so to do that, we need to get E to the 0.03t by itself. So we're going to divide by 4,500. Okay, so we'll come in, I'll put my calculator over. So we've got 6,000 divided by 4,500, which is 1.33333. Okay, and it keeps on going. That's equal to E to the 0.03t. Now, we want to get rid of that E. In order to get rid of an E, we're going to have to take the natural log. Because remember, a natural log will cancel out the E. So if we take the natural log of the right side, we'll also take the natural log of the right. When we do that, the natural log will cancel out the E. So we end up with 0.03t equals the natural log of 1.33333. So we need to figure out what that is. So natural log, which is the button below log, grab that 1.33333, going on forever and ever. Use the whole thing. Hit enter. We get 0.287682876, and it keeps on going. Okay, so that's equal to 0.03t. So we took the natural log, or if it's E, of both sides. So the log if you just have a log, or natural log if it's a base E, of both sides to get rid of the base, which is what we did here. Okay, finally we need to solve for your variable. Okay, so to get T by itself, we're going to divide by 0.03. So we're going to take that number, just hit divide by 0.03. So 9.5, we're going to go to 2 decimals here, so 9.59. So this will take 9.59 years to get to $6,000. Okay, so a little bit over 9.5 years to get to our answer. And I'm okay with you leaving it as a decimal. Okay, so that's when you're given a problem where you're going to have to use logs or natural logs to solve it. That's an exponential problem. You have exponents in your actual equation. The other type of problem we're going to look at, which we'll solve similarly, same concept, is logarithmic equations. So here it tells us the apparent magnitude of a star is a measure of the brightness of the star as it appears to observers on Earth. The apparent magnitude m, so our magnitude is m, of the dimmest star that can be seen with a telescope is given by the function m equals 5 log d plus 2, where d is the diameter, so d is our diameter in millimeters, of the telescope's object length. The telescope can reveal stars with a magnitude of 17. What is the diameter of the objective lens? So again, first step is to plug information into the problem. So we're given the equation m equals 5 log d plus 2. Okay, that d belongs to the log. D is the diameter, m is the magnitude. It gives me a magnitude of 17, so that's my m value. So we're going to say 17 equals 5 log d plus 2. We want to solve for d because we want to know what the diameter is. So the next step is going to be to isolate the log, okay, or the natural log if you have a natural log problem. Okay, so we need to get the log by itself. So subtract 2. 15 equals 5 log d. Okay, we still want to have just the log, so divide by 5. You get 3 equals log d. In order to get rid of the log, we want to exponentiate both sides. We're going to base it to get rid of the log or natural log. Okay, or again, you can also rewrite it. So we know that if we have a log and it doesn't give us a base, we assume this base is 10. Okay, so to get rid of the log, we'd either base both sides of 10. So we go 10 to the third equals 10 to the log base 10, or we can rewrite it as 10 to the third power equals d. Okay, so this is rewriting 10 to the third equals d, or again, when you have 3 equals log base 10 of d, you can base 10 it. So 10 to the third equals 10 to the log, cancels out. You'll have 10 to the third equals d. Again, either way, you get the exact same thing. So 10 to the third power is 10 times 10, which is 100, times 10, which is 1,000, equals d. So fourth step was to solve. So our diameter d is 1,000. This says in millimeters, so this would be 1,000 millimeters. Would be the diameter of the lens. All right.